Alright guys, this is the 4.345 key for the review quiz. We're going to start on the back here on the unit circle, and I suggest you start back here. So, the unit circle itself won't be necessarily assessed, like filling this in, but you will be provided this. You should be able to fill in this unit circle from memory. Okay, so again, this is a review. We have feel free to skip this if you're good on unit circle, but I'm just gonna do, okay, well that's a bad start at 0. We're just gonna do it for just in case you have any confusion. So degrees go 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330. So what we're doing there is we're just adding 30 each time all the way around. That's also the same as pi over 6, right? So with 0 radians and pi over 6 radians, then we just add pi over 6 each time. So we got 2 pi over 6, that's pi over 3. Change pens here. We got pi over 2, 3 pi over 6 or pi over 2, 4 pi over 6 or 2 pi over 3, 5 pi over 6, 6 pi over 6, which is just pi, 7 pi over 6, 8 pi over 6 or 4 pi over 3, 9 pi over 6 or 3 pi over 2, 10 pi over 6 or 5 pi over 3, and then 11 pi over 6. Okay, just adding pi over 6 each time. Then for the middle, for like the 1.5 slices, that is 45 degrees. So we do 45, and it would be 90, then it would be 135, then it would be 180, then it would be 225, 270, and then it would be 315. And then it's pi over 4. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, oh sorry, that would be there, 5 pi over 4 is here, 6 pi over 4, 7 pi over 4, okay? So that's degrees, and that's the radians. For the coordinates, okay, we know this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. And then we have the order, so it's root 3 over 2 is the long side, it's root 2 over 2 is the medium side, it's 1/2, it's the short side, then root 3 over 2 long y, medium y, and then the short y. And then we've continued filling this in by kind of reflecting these values and looking at the similar triangles, right? So here, negative 1/2, negative root 2 over 2, negative root 3 over 2, root 3 over 2, root 2 over 2, 1/2, then negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2, negative 1/2, negative root 3 over 2, 1/2, negative root 3 over 2, root 2 over 2, negative root 2 over 2, and then root 3 over 2, negative 1/2. Okay, unit circle. All right, let's begin with the questions. So first kind of questions you're going to get are just evaluating either like the 6 trig functions, so sine, cosine, tangent, cosecant, secant, cotangent of various degrees and radians. And to do that, you use the unit circle. You use unit circle. And we just find these values in the unit circle. So sine 135, if you forgot, you just go to unit circle, find 135, and you see sine is the y value, so it's root 2 over 2, right? Remember that sine is the y value, and then cosine theta is the x value, okay? The x coordinate. So sine 135 is root 2 over 2. Cosecant 330. So first of all, cosecant is 1 over sine. You want to write that identity, and then we'll find 330. 330 is right here. So sine of 330 is negative 1/2. Okay, so it's going to be 1 over negative 1/2. That is going to be negative 2. Okay. Last one, cotangent 7 pi over 6. That's going to be cosine 7 pi over 6 over sine 7 pi over 6. So what is that? So cosine over sine, 7 power 6. 7 power 6 is right here. Cosine divided by sine. So negative root 3 over 2 over negative 1/2. So negative root 3 over 2 over negative 1/2. This is the keep change flip, right? So negative root 3 over 2 times negative 2 over 1. Cancel, cancel. That's just going to be root 3. Okay? Because these cancel, the negatives will cancel, so just root 3 over 1, which is root 3. Okay? For these three, so these are similar. You are going to find the coterminal angle in unit circle. What that means is like between 0 and 360 or between 0 and 2 pi, then evaluate. So here, 17 pi over 4, that's not in the unit circle, as you can see. That's not in here. It's like 17 pi over 4 would be like, it's more than one rotation around. So what we're going to do before we evaluate is we're going to take 17 pi over 4 and we're going to take away 2 pi. So we're going to take away 8 pi over 4. And then we're going to get 9 pi over 4. That's still more than one rotation. So we're going to take away another 8 pi over 4, and we're going to get pi over 4. So really, 17 pi over 4, sine of 17 pi over 4 is the same as saying sine of pi over 4. Okay, and sine of pi over 4 we know is root 2 over 2. Okay, so because these angles are beyond the unit circle, beyond like 0, 360, we're just adding or subtracting 360 or 2 pi to get within the unit circle. So in this case, like negative 810, that's like, again, beyond the unit circle, beyond 0 to 360. So let's add 360 a couple times to get it back in the unit circle, right? Or get it back between 0 and 360 degrees. Okay, so we're going to add 360, and we're going to add 360 again. So negative 810 plus 720. Make sure I got this right. That's negative 90. So we'll do one more. So that is just 270. So this really is cosecant of 270. And cosecant of 270, again, that's 1 over sine 270. And sine 270 is negative 1, so this is 1 over negative 1, so it's just negative 1. Okay, last one, secant 9 pi over 4. So again, we'll just do 9 pi over 4 minus 8 pi over 4 to get back within 0 and 2 pi. That's pi over 4. Okay, so what we're doing is secant pi over 4, and that's the same as 1 over cosine pi over 4. That's the same as 1 over root 2 over 2, which is the same as 1 times 2 over root 2, which would be, when you multiply top and bottom by root 2, you would just get root 2. Okay, just to confirm this, you know what I mean? If you take root 2 over root 2 and you multiply by root 2 over root 2 to rationalize it, you'll get 2 root 2 over 2. These cancel, and so you just get root 2. Okay. Next one. These two, you evaluate those by drawing the triangle. It's called a reference triangle. You go and then finish the triangle, then solve. Okay, so let me show you what that means. So here, this is our reference triangle here. You just go straight to the x-axis. To the closest x-axis, right? And the acute angle that's formed is your reference triangle. And so because this is root 15 comma 7, that means that this distance here is root 15, and this distance here is 7. And we want sine. So sine of theta would be 7 over this hypotenuse here. We're going to get the hypotenuse through Pythagorean theorem. So h squared equals 15 plus 49. That's 64, right? H squared equals 64, so h must equal 8. Therefore, sine of theta equals 7 over 8. This, you're going to do the same thing. You go straight to the x-axis. This is going to be your reference angle here. Cotangent is adjacent over opposite. Because of these coordinates, this side is negative 13. This side is 17. This is my angle. Adjacent over opposite. Cotangent theta would be 17 over negative 13. So I actually didn't need to solve the triangle. I just already had the sides I needed to find cotangent. Okay, last from 4.3 is when you're given the ratio and you're told, maybe you're given some other information, and then you do this. It's very similar to the problems we just did. You solve these by finding the quadrant, draw a triangle, and then evaluate. Okay, so here we go. Here's an example. So we're going to draw the quadrant. Sine of theta is negative. If sine of theta is negative, I'm in my bottom two quadrant, because this is basically saying y is less than 0. That's essentially what that's saying, right? So we're in these two quadrants, but cosine is positive, so I must be in this quadrant here. So I'm going to draw my reference triangle here. It's always going to be like the opposite side will always be perpendicular to the x-axis. Okay, so this is my theta. Cosine is 24 over 25, so that means my adjacent is 24, this is 24, and my hypotenuse is 25. So I need this length here. So I need to use Pythagorean theorem to get, so remember I'm looking for, I need to find all the 5 remaining trig values, so I definitely need this side here. So it's 24 squared plus x squared equals 25 squared. 24 times 24 is 576. 25 times 25 is 625. 625 minus 576 is 49. Therefore, x squared equals 49. Therefore, x is 7. But because we are below the x-axis, it's going to be negative 7. So now that I have all my side lengths, it's pretty easy to find the remaining 5 trig values. It's going to be, I need sine, I already have cosine, so tangent, secant, cosecant, and then cotangent. Don't forget the theta. Okay, so sine, opposite over hype, negative 7 over 25. Tan, opposite over adjacent, negative 7 over 24. Secant, the hypotenuse over adjacent, so 25 over 24. Cosecant, hypotenuse over opposite, so 25 over negative 7. And then adjacent over opposite, so 24 over 25. No, sorry. Adjacent over opposite, 24 over negative 7. Okay. All right. This one, similar process. Draw it out. Cosine's negative. Cosecant is positive. Cosecant, remember, that's 1 over sine. So this is really saying that my sine is positive. So I'm over here because cosine's negative, but sine is positive, and that happens right here. So draw out your angle. It doesn't really matter what your angle looks like, right? It can be, you're just drawing a triangle here and you're going to label it. Cosecant is 3 root 7 over 7. And cosecant is the same as 1 over sine, which is the same as hypotenuse over opposite. So that means my hypotenuse is 3 root 7. My opposite is 7. So we got to do Pythagorean theorem to find this. So 7 squared plus x squared equals 3 root 7 squared. So that's 49 plus x squared equals 9 times 7. So 82. sorry, 63. Whew, it's been a long day. 63. All right, 63 minus 49 is 14. So x squared equals 14. So x equals root 14. But it's going to be negative because it's the cosine's negative, right? So that has to be negative. We're in this quadrant 2. Okay, so now fill it out. We have our triangle. Now you're just labeling that, right? So it's sine theta, cosine theta, tan theta, cotan theta, and then we need secant theta. Sine theta would be opposite over hypotenuse, so 7 over 3 root 7, which would be, if we rationalize that, that would be 7 root 7 over 21. Here, I'll write it out. So 7 over 3 root 7. I'll leave it without rationalizing it, and then I'll come back. Cosine would be negative root 14 over 3 root 7. Tangent would be 7 over negative root 14. Cotangent would be negative root 14 over 7. And then secant would be 3 root 7 over root 14. Or negative root 14. Okay. All right. So rationalizing those, just so we're clean on that, I'm going to write them out here. So 7 over 3 root 7, multiply both top and bottom by root 7, you would get 7 root 7 over 21, which is the same as root 7 over 3. That would be sine theta. For cosine theta, you would get negative root 14 over 3 root 7 times root 7 times over root 7. That's 14 times 7. 14 times 7, root 98, negative root 98. Okay, over 21. Root 7 times root 7 is just 7, sometimes it's 21. Then we'd have tan theta, which was 7 over negative root 14. So we multiply that by root 14 over root 14. We would get 7 root 14 over negative 14, which would be negative root 14 over 2, because that simplifies, those are both by 7, and the negative sign can be in the either denominator or the numerator, so we can, that's how that got switched to the numerator. Cotangent is fine, and secant theta is 3 root 7 over negative root 14, multiply top and bottom by root 14, and you'll get 3 root 98 over negative 14. And that's it. I can't do anything more there. Okay, those are done. Now we're done with 4.3. We're going to move on to graphing. So graphing, we start with the basics, sine and cosine. And remember that sine and cosine come from the unit circle, right? So sine is telling you the y values, and we start at 0. So we go 0, and then we work up to 1, then we come down to 0, and then we come down to negative 1, back to 0. Cosine starts at 1. Sine starts at 0, cosine starts at 1. That's key. Cosine goes from 1 down to 0, down to negative 1, back up to 0, and back up to 1. So cosine starting at the top, and then cosine starts at the top, sine starts in the middle. Sketch it. I'm going to say this is 1, and this is negative 1. All right, sine up, down, down, middle. Repeat. Okay? Period is 2 pi. Domain is all real numbers. The range is from -1 to 1, and the amplitude is 1. Remember that this is the amplitude here, that distance, and the midline is y equals 0. Cosine, it's very, very similar, but it starts at 1. Start at 1, go to 0, -1, back to 0, up to 1. And that repeats over here. Same thing. Period is 2 pi. Domain, negative infinity to infinity. Range is -1 to 1, and amplitude is 1. Every single sine and cosine can be, function can be written as a sine or a cosine, because cosine is just sine, but shifted pi over 2 to the left, right? And sine is just the cosine shifted pi over 2 to the right. Okay, so they can be written as each other. So if you're like, oh, well, is this sine or is this cosine? Well, it can be both. And what you'll see in the questions is that if it's multiple choice, well, you know what to do, or you're graphing it, right? Okay. Or maybe you're told, write it as a sine. It'll tell you specifically which one to write as. Okay, now we have transformation. So once you understand how the basics of sine and cosine, then you have to transform them. And that follows this structure here. So A is affecting the amplitude. So remember, absolute value of A is the amplitude. That's the vertical stretch. All right, vertical stretch. K is affecting the periods. This is horizontal stretching or shrinking. Is 2 pi over absolute value of K. Will get you the period. Okay, that's important. Definitely know that formula. Negative A will also reflect x-axis, and then negative K reflects y-axis. Okay, B, this is phase shift, it's called. So shift B units right when it's negative, right? So if you subtract 3, you're moving 3 to the right. Okay, and then C is the vertical shift, or the midline. So midline equals C. When we're doing transformations, you want to follow the order of operations. So multiply, divide, then shift, if that makes sense. So if you're doing a transformation, we're going to do this multiplication part first, and then you would do any kind of shifting. Okay? You don't add it and then multiply. You multiply, then you add. Okay? All right, so this example, label the period and midline, graph the following, label the x coordinates, the zeros. Okay. So period here is 2 pi over 3 equals the period. And my amplitude is 1/2. And then midline is still y equals 0. So this is going to look like a sine wave. In fact, I can just draw a sine wave since it gives me no, giving no x coordinates is actually really helpful. Because then you can label it yourself, and you can just, sine is going to look like a sine wave, but what's going to change are the axes, how high and how low we go. So this would be 1/2 up here, and this would be -1/2 here. Now the period is 2 pi over 3, so that means this value must be 2 pi over 3, and then this would have to be 4 pi over 3. That makes sense? And then this would have to be 0. And so then it's okay, well, what is this point here? What is this point here? Well, that's halfway between 2 pi over 3 and 0. So that would be this divided by 2. So this would just be pi over 3. So that would be pi over 3, 2 over 3, then this would be 3 pi over 3, or pi. Okay, so a period is 2 pi over 3, so you're like, okay, draw a full wave, that's 2 pi over 3. And then each of these points here is like a half or a quarter of that value. So you can label these points by like dividing it into quarters or dividing it into halves to find that. Like this value here would be pi over 6. So pi over 6, that'd be pi over 3. This would be pi over 2. Pi over 6, pi over 2, 2 pi over 3, 3 pi over 3, 4 pi over 3, this would be 5 pi over 3. Sorry, 5 pi over 6. 6 pi over 6, and this would be 7 pi over 6. Okay, so if you're like, let's show you how did you do that. So one more time, like this distance from here to here is 2 pi over 3, and I know that from this. And so it's like, well, how do you get these values here? Well, you're taking that 2 pi over 3 and you're dividing it into fourths, right? Every fourth, we're going up, we're going up, we're going up. So if you did 2 pi over 3 divided by 4, you get pi over 6. And you could add pi over 6 each time. Okay, so here it says label the x coordinates with zeros. So the ones that are important are the pi over 3, the 2 pi over 3, the pi, and then the 4 pi over 3. That's this point here. Okay, hopefully that made sense. All right, next one, cosine 3 cosine x plus pi over 4 plus 3. So cosine, it's got some shift. We're moving up 3 and moving up 3 again. So we've got an amplitude of 3. So I'm going to say a equals 3. Midline is y equals 3. Period still 2 pi. So we're at 3 for the midline. I'm going to sketch that here. And then our amplitude is 3. So it means I'm going to go 3 up, 3 down. So I need to label like that 0 and then 6. That's like going to be our kind of like up and down. Okay. And then we're moving pi over 4 to the right. So to the left, my bad. Pi over 4 to the left. So if we think about, well, what is cosine of pi over 4? Right, cosine of pi over 4 is root 2 over 2. So it's going to be, rather than it being a peak here, it's going to be, the peak is kind of over here, if that makes sense, and it's coming down here. So we shifted that peak pi over 4. This is going to be negative pi over 4 right here. Does that make sense? So the peak is over here. So we would go down, back up, be 1 full rotation, down, and back up, be another full rotation. This distance from here all the way to here is 2 pi. The distance from here all the way to here is 2 pi. So from pi over 4 plus 2 pi all the way to here would be 7 pi over 4. 7 pi over 4 all the way over here would be 15 pi over 4. I'm just adding 2 pi. Therefore, the middle of this, right, we would add a pi from negative pi over 4. So negative pi over 4, this is going to be 3 pi over 4 here. So this middle point here, this is going to be 3 pi over 4. And then this one would also add a 5, so this would be 11 pi over 4. Okay. Up to 6, down to 0, 2 pi periods. And so each half is pi, right? So pi here, pi here, pi here, pi here. So again, just to make it clear how I got 7 pi over 4, 15 pi over 4, just taking negative pi over 4, and I'm just adding 2 pi and adding 2 pi to get my next values. Okay? All right. Cosecant, secant. So cosecant and secant also very similar, like cosine and sine. Cosecant is 1 over sine. So the way I remember it is, okay, well, I'm going to have vertical asymptotes when sine is 0. Since sine is 0 at every 0 and every factor of pi. So here, 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 here. Cosine is 0 every pi over 2. plus pi. Okay, and then sine is 1 at pi over 2. Therefore, cosecant will also be 1 at pi over 2, and then we start our pattern here of alternating. Here, same thing. Cosine of 1 is 1, so then we start our pattern of alternating. So period is still 2 pi for both of these. The domain is like x cannot, or theta cannot equal, I don't care if you write x or theta. Theta cannot equal pi k, where k is an integer, and the asymptotes happen at pi k, where k is an integer. And then the range is -infinity to -1, union 1 to infinity. Over here, it's at pi over 2 plus pi k. And the domain against theta cannot equal pi over 2 plus pi k. And the range is the same, -infinity to -1, union 1 to infinity. Okay, tangent and cotangent share similarities with these in terms of the asymptotes, because tangent is sine over cosine, right? Sine over cosine. It's where cosine 0, so it's like secant. It's the same vertical asymptotes as secant, so it's going to be negative pi over 2, pi over 2, 3 pi over 2, negative 3 pi over 2. And this is cosine over sine, right? It's the same as cosecant, because cosecant is 1 over sine, so it's going to be every 0, pi, 2 pi, negative pi. And then what you have to remember is tangent goes low to high, like this, through 0 in the middle. And then cotangent goes high to low, like this. The main difference here is that the period is pi. The domain is same as this, so theta cannot equal pi over 2 plus pi k. Domain theta cannot equal pi over pi k. Asymptotes are pi k, pi over 2 plus pi k. And then the range is all real numbers. Okay, so transformations with cosecant, secant, and cotangent, tangent. Not the only thing, but the main thing you need to remember is that the period of tangent is pi. So instead of doing, for cosine, sine, secant, cosecant, we use the formula 2 pi over k for the period. But for tan and cotangent, we use pi over k. Okay, that's the main thing. Okay, all right. Let's do some graphing. Let's wrap this up. All right, 3 secant x minus 1. Okay, so secant is, again, I'm going to remind myself, 1 over cosine. Okay, so that means I'm going to start here. I'm going to multiply by 3, then I'm going to subtract 1. So I multiply by 3, then subtract 1. I would be, instead of starting at 1, I'm starting at 3, but then I minus 1, I'd be at 2. So this is 2 right here. Down below, over here, okay, let me start sketching a little bit here. So I'm going to sketch my asymptotes. I'm not going to label them yet. I'm just going to, I know that they're going to be there, and then I'll sketch them in a moment. There's no horizontal shift, so I don't need to worry about like moving the 2 over. My point down here would be -3, but then -1, so it would be really at -4 here. Okay, so I'm going up, down, up, down, up. Okay? Period is still 2 pi. Okay. Let's see the next one. 2 cotangent to parentheses x plus pi. Okay, so cotangent, it's got a vertical stretch of 2, which isn't going to really do much to cotangent other than just make those curves steeper. Let's go ahead and well, we have some shifting here, so we got to be a little careful. Our period is going to be shrunk, so our period is now pi over 2. So cotangent again is sine over cosine. So it's when cosine is 0, which is at pi over 2. Sorry, good catch here. It's cosine over sine. What am I doing? It's cosine over sine. So it's when sine is 0, pi, etc. Okay. So my period is pi over 2. I've got this vertical stretch. I've covered 2 of them. Let's now talk about this shift. So what's this shift gonna do? Well, it's actually not gonna do anything, guys, which I know is kind of weird. It's not gonna change how it looks. I'll show you why. So let me sketch, for example, like what just the regular. Right now, what I'm sketching is 2 cotangent 2x. I'm not gonna do anything with the plus pi right now. I'll show you why they're the same. So what you'd be telling me is that, well, this has got to be pi over 2. This has got to be pi. This has got to be 3 pi over 2. This has got to be 2 pi. And the way it'll look is, because it's cotangent, it'll be going down, and it'll just be like a little bit steeper than normal, right? So something maybe more like this. It doesn't have to be perfect. Okay, clearly not perfect. So if we then shifted this pi to the left, that means that this asymptote is now going to be here at 0, and this asymptote would now be here, and this asymptote would not be here. Because it directly aligns where another asymptote is, this is just the same as saying 2 cotangent 2x plus pi. Now if it said plus like pi over 4, that's where it would be a little bit different, where it would shift like here. This point would be here, and this point would be here, and this point would be here, and this point would be here. So that would change things. But because the period is pi over 2, and you're moving it by a value that is divisible by pi over 2, it looks the same. Okay, now goes there. All right, last 2 here. We got tangent and another cotangent. Okay, so tangent here. Okay, so we are shifting in a way that's going to affect us here because we have this minus pi over 4. So up here above, I'm just going to sketch a little tan. Normally we'd have tan at, so my period is still 2 pi here. Oh, sorry, my period is pi for tan. Period is pi. Normally it would look like this, and this would be pi over 2, and this would be negative pi over 2. But we're going to shift pi over 4 to the right. So this is going to move, this is going to move. So it's going to be here. This is going to be negative pi over 4. And then instead of pi over 2, it's going to be at 3 pi over 4 here. Then, okay, tan goes down up. The 2 just makes it a little bit steeper, and the minus 1 is going to make it so that midpoint is not at 0, it's going to be at negative 1. And it's just going to shoot up like that. The 2 I'm not that worried about. Like, it's kind of hard to show that. It essentially just means that it gets steeper going up and down versus a regular tan. But the pattern itself is not as important as like the general shape. That's what I care about. And then these specific points, like I'm looking for this specific point being at negative 1, and I'm looking for these being labeled correctly. So then since the period is still pi, we're just going to add pi each time here. So this would be 7 pi over 4, and this would be 11 pi over 4. Again, we do the same. So it would be negative 1, we negative 1, we just go up. We just go up. I'm sorry that this one is like bigger. That's not on purpose. These were supposed to be even. Okay, last one, cotangent. So we've got that 2 in front, making it steeper. It's going down, but it's just a regular cotangent. This is cosine over sine. And that means that at 0 and at pi and at 2 pi and 3 pi, we'll have these vertical asymptotes. And the only change here is that it's going to be down 1. And it will be going down because it's cotangent. All right, we did it. So hopefully that made sense. That's what you can expect in the test. On the quiz rather, so you're going to get some problems with World War 3, some graphing problems, and then some multiple choice like your classwork. I wish you luck. Go over the delta, make sure that's all done by the quiz, and I have a great long weekend otherwise. All right, see you.